So let's practice what we learned from the last example. I want to solve for p. The first thing that I need to do is to move this u over. Since it's addition and subtraction, when we move the u over, it simply changes its sign. So we have e minus u is going to be equal to p squared over 2m. Now, in a way, I can do away with the addition and subtraction if I think of this as one term. Since now thinking of this as one term, all I've got are terms which are being multiplied and divided. I can move this, the 2m, diagonally up. So I've got 2m quantity e minus u is going to be equal to p squared. And then, of course, what I can do is take the square root of both sides. And there we go. That's p. Okay, let's take a look at this example. I've got 1 over r1 plus 1 over r2 equals 1 over r equivalent. And what I'd like to do to both sides is just flip them. So what I've got is r1 plus r2 is going to be equal to r equivalent. And we're done, right? As it turns out, wrong. Let's take an example. 1/4 plus 1/4, that's equal to a half. Does that mean that 4 plus 4 equals 2? I don't think so. Before you flip, and really flipping is just cross multiplying, what you have to do is to give both sides the same common denominator. So this is not going to work. However, what we can do in order to have a common denominator is that we can change our algebraic rules ever so slightly. Normally, whatever you do algebraically to one side, you have to do to the other side. The exception to that is that you're allowed to do something to one side, not the other side, provided that it's just multiplying by 1. So I think what I'm going to do here is just to multiply both sides by, well, just this one term by 1, or in other words, r2 over r2. Similarly, what I'm going to do is I'm going to multiply just this one term by 1, or r1 over r1. Now what I've got is r2 plus r1. This was r2 over r1, r2. This is r1 over r1, r2. They have the same common denominator now, so that I can add them in the numerator and keep the same common denominator. And 1 equals 1 over r equivalent. Now, I can think of this as one term, and in your mind's eye, you can just move terms diagonally. Essentially what I'm doing is now I'm just flipping both terms, and what I would get is that r equivalent is going to be equal to r1, r2 over r1 plus r2. Now, just one word on notation. If you have something like the sine of x squared, you can also write that as sine squared x. So once again, if you have something like sine x cubed, you could write that as sine cubed x. That's the same notation. However, if you have something like sine x to the -1 power, you can't write that as this, because that's our notation for arcsine. That would be the arcsine of x, whereas this would be 1 over the sine of x. So you have to be a little bit careful in your notation. In the unlikely example, you're trying to put something to the -1 power. Otherwise, just realize this is notationally the same. Let's take a look at this example. We have the sine squared of quantity ky plus 7 equals m over j. This really could read the same thing as sine of ky plus 7 squared. So the first thing that we're going to do in trying to unlock y is to take the square root of both sides. So this will be sine of the quantity ky plus 7 is going to be equal to the quantity m over j to the 1/2 power, square root of that. Now to get rid of the sign, we need to take the arc sign. So ky plus 7 is going to be equal to the arc sign of the quantity m over j to the 1/2 power. Now we're trying to solve for y, so we have addition and subtraction. I can't just divide k by both sides because I would have 7 over k. So let's move the 7 over. When we move the 7 over, it changes its sign. So ky is going to be equal to the arc sign of the quantity m over j to the 1/2 power. And that would be minus 7. And then, of course, what we can do is move the k diagonally over here. And we're left with y is going to be the arc sign of the quantity m over j to the 1/2 power minus 7 over k. And that's our answer. Let's take a look at this. yr minus k quantity x plus f squared equals k. And we want to solve for that for x. Let's see if we can do our algebraic gymnastics tricks as much as we can in our mind's eye. I want to move this term over, get rid of the minus sign. I want to move this like so. So the first thing is I would have yr minus k is going to be equal to k x plus f squared. I don't want to have to deal with this square root of k, so I think what we're going to deal with is to think of this as one quantity, bring the k over, and then take the square root. So I would have yr minus k over k to the 1/2 power is going to be equal to x plus f. Now let's just bring the f over. It's going to switch its sign. So we've got yr minus k over k to the 1/2 power minus f is going to be equal to x.